Hi, welcome back. In this video, we're going to take a look at some special trigonometry with dealing with asymptotes. And we're just going to kind of memorize what these look like. So here we go. So if we want to graph tangent of x, let's say, we know from pre-cal that tangent of x is sine of x over cosine of x. To find the asymptote, we just set the bottom equal to 0. X can't be anything with a pi over 2, like pi over 2, 3 pi over 2, and so forth. So if I were to graph it to get tangent of x, well, here is negative pi over 2 and like pi over 2. And this works for all the pi over 2's. It's the same. And hopefully we remember what tangent looks like. It looks kind of like a cubic graph in between each and every one. So I can say, oh, look, what's the limit as x approaches pi over 2 from the left of tangent? And I can look at that. So if I'm looking from the left side at pi over 2, I know we're approaching positive infinity. That's it. Real quick and easy. Cotangent's kind of the same, but for cotangent, we can't look at the pi's or 0. So we got 0, pi, negative pi. And cotangent is really just the flip of tangent, and there it is. And it's ugly, and that's what it looks like. It's ugly, but hey, you're not being graded on it, so that's nice. So if we approach pi from the left, we're approaching negative infinity. Negative pi from the right, we're approaching positive infinity. And it works for all the pi's. All right, to graph secant, we can't be the pi over 2's. Secant follows with tangent because secant is 1 over our cosine of x. So if we were to graph this, ready? Same thing, negative pi over 2, pi over 2. And remember, we really can't graph secant, so what we really do is we kind of graph cosine of x. And cosine kind of looks like this. That's our cosine graph. And what we're looking for, like if here's our asymptotes, we're going to make these little bumps and valleys like so. So there's cosine, or secant of x. Cosecant is kind of very similar to it, except for now we can't be the pi's. 0, pi, negative pi. There's my asymptotes. Or 0, of course. Always starts in the positive. Very simple. In the first quadrant, everything has to be positive, okay? Everything just has to be positive. And then we just alternate our signs, like so. That even works for secant. We're positive in the first quadrant, and we alternate in all the others. So it looks like that. Very simple to do. And now we can answer some questions. So like, let's say we want to find, oh no, what's the cotangent of x as x approaches pi from the left for cotangent, right? So I'm going to graph it. Cotangent, my rule, it says it can't be pi. So 0, pi, negative pi. I just sketch it. Going down, going down, going down, going down. There it is. There it is. There's my cotangent graph. Don't tell your pre-cal teacher. As we approach pi from the left, we are going to negative infinity. So we know that our answer is just going to be negative infinity. Same thing for secant of x, looking at the pi over 2's. I only really need the 1. I'm looking at what happened as we approach just pi over 2 from the right. So if I think, right, here's my first quadrant's over here, and then it's going to be down over here. So there's my secant graph. As we approach now pi over 2 from the right side, we can take a look. Notice this is going down the asymptote, so it's going to approach negative infinity for us. So, and there we go. Very quick, very easy to do. Hope you enjoyed this little video for these trigs. We'll take a look at some on your homework tonight too, okay? A couple things, but before I begin, I almost forgot. I had to go back and edit out number 4. You might have made, on my previous video, you know, I made a mistake on number 4. And it was a very simple mistake. And I want you guys to know, mistakes do happen, and it's okay to make mistakes, but always be willing to fix them. Remember when I graphed the function, I graphed it correctly, but it didn't match my answer, negative infinity. But I wasn't thinking, when I picked my number to the right of negative 3, that negative 2 right there, notice what I did. I did negative 2 plus 3 was a negative 1. Well, that's not true. This is a positive 1. So now I got a positive over a positive, which makes it a positive infinity. So the graph here was absolutely correct. It was everything else I did wrong. Mistakes happen. Now notice that I would not have been able to find my mistake unless I showed my work. And that's why you show your work. We don't show the work when we get it right. That's easy. We really want to show our work when we make a mistake so we can go back and fix it and learn from it. All right, but the other thing I want to point out was this. It is not enough to say undefined or D and E in a lot, unless we get a case where there's no right or left. Plus or minus infinity is going to give us more information, and that's why we like it. That's why this lesson is so important for us. Okay, so I hope you enjoyed this video, and I'll see you in the next one when we start talking about what happens at a horizontal